Hello, Harun. Can you hear me? Yes, you can start. Yeah. Yes, Harun, you can start the session. The floor is yours.
Hey, hey people, can you hear me? Can we start the session? Can someone unmute their mic and confirm if I'm audible so that you can go on?
Yes, you're audible, and yes, you can start the session.
Okay, thank you. So I think I'll start by introducing myself, but I'm Harun. Yeah, I'm Harun Mbaabu. And currently I am a machine learning engineer and a machine learning instructor at Bonifu College. I'm also the founder of Flax Tech Academy. So I think I'll start by introducing machine learning. Yeah, the session is on machine learning, where we'll cover the types of machine learning, categories. We'll also look at ensemble learning, and after that, we'll also look at, I think it's possible to have like 3 or 2 demo and maybe try a session on maybe a few minutes on any ensemble learning model. So yeah, so I won't be using any presentation until I reach the part that I will need. I will be required to share my screen to show you the demo. Yeah, so in data I will start with, yeah, I expect many of you are learners in the Data Science East Africa January bootcamp, which is in its 4th week. Yeah, we have been doing the sessions, weekly sessions, daily sessions sometimes. Yeah, and I think it has been helpful. We have covered the machine learning libraries in Python, where we have added NumPy. We have also added Seaborn. We have added Matplotlib and Pandas. In the demo session, I will show you a simpler way to import all those libraries using something that we call PY Forest. So I think I'll start by what is machine learning, but a lot of people know what is machine learning. So in the chat box, can someone type what is machine learning according to you? What do you think machine learning is? So I expect answers from you so that you can go on. Yeah, Junior. Mushila Junior is saying it's a subset of AI. Anyone with an answer, you can unmute your mic and respond too. Okay, if as you type, I will introduce machine learning as a subset of AI that deals with creating machine intelligence system. These systems can learn on their itself and improve with time. Machine learning has a lot of application, and I'll mention a few applications that are in play. I'll also mention a few applications that have been personally involved in development. So I think you can apply machine learning in agriculture, the health sector, in smart advertisement. Yeah. And one good example that I like giving is the one that is currently in play in Nairobi, where people where advertisement screen that is placed exactly opposite University of Nairobi. Yeah. There is a advertisement screen where the screen, when it detects the specific type of the car that is coming or ongoing, it identifies that car and give an advert on the side. Okay, the advert that is given on that screen is related to that car. So you can build on that model. Like, you are thinking of having the same model which gives the advertisement depending on the time it is. Okay, let's take an example of it is in the afternoon or lunchtime. Students from University of Nairobi are from classes and they are very angry, wako na njaa sana. So what will you advertise that time? You will advertise the best cave with the best offers of meals allowed, and that is one application of machine learning that you use in agriculture. So that is one application of machine learning. The categories of machine learning that we have that I had is we have supervised running. Yeah, that is where we use labeled data in training our model. We also have unsupervised running, where we are finding patterns from input data without reference to labeled outcomes. We also have clustering, where the machine learning learns on itself and improves with time. So on supervised running, we have more categories on supervised running, where we have uh, regression and the classification. So we have two major categories uh, in machine. We have regression and classification, and types of regression models is which one are the ones that I mentioned. We have linear regression, we have decision tree, we have random forests, and even neural networks are in the part of regression models. Then you meet there is classification model. In classification model, we have logistic regression, we have support vector machine, and we have naive bias. We also have random forests and neural networks, the decision tree also in classification model. Now the difference comes when you want to clarify the difference between uh, classification and regression models. So the big question will be the kind of the data that you use in regression models. That is continuous data. Then when you come to classification, that is where you use discrete data set. And I would like to hear from you just on the chat box. Can someone type the types, or give an example of continuous data and discrete data? Kindly someone help us on giving the differences between the uh, continuous and discrete data. You can even unmute your mic and comment maybe. I just want to hear who has a good clarification of the difference between discrete and continuous data. Hey, am I alone? Can someone please unmute your mic or comment on the chat box what is the difference between discrete and continuous data before we go on? Okay, someone is saying it don't have any clue. Discount mainly involves the whole number data, while continuous data contains decimals. That is wrong. Anyone else with a clue? Okay, sometimes you're given a problem, and you as a machine learning engineer or a data scientist, you have to specify the model that you use. Does that model belong to discrete or continuous? Regression or classification model? Which one will you use best? So you have to choose depending on what you want to predict. Okay, I will try to give a brief description of what is discrete continuous data. So discrete are whole numbers like 1, 2, 3, and 4. While when we come to, continuous data are whole numbers like 1, 2, 3, and 4. While when we come to discrete, they are those data that have texture, like yes or no, something like that. You want to classify if something is a dog or cat. That is a problem that you use. That is a problem you use classification. Example, I'll give when you want to classify, is this one a dog or a cat? Apple, in that case, you'll use a model that is related on classification models. When we want to predict the stock price, the stock exchange market, in such a situation, you'll be required to use you're handling continuous data. So in that case, you'll use any model that belongs to regression models. So another case I'll give you is when you want to predict the outcome of any match in EPL match. So in that situation, and I said you check that data on EPL, any football match, you can check their data. I shared that on WhatsApp yesterday. They also shared on Instagram, on Slack channel. So when you want to predict if there is the home team, the away team, or it will be a draw, is it the home team that will win? Is it the away team that will win, or will it be a draw? So in such a situation, we are dealing with H, maybe for home team to win, A for away team to win, and D for a draw. In such a situation, that is, uh, you're handling discrete data, and in such a situation, either you can convert it to or zero, maybe zero to represent H, then one to represent maybe A for away team to win, and maybe you can have two to represent the draw, which is a D. So those are such situations where we are dealing with discrete data. The other classification. Oh, another thing I wanted to mention there. Kindly make sure that you check on Bayes' theorem. Well, when we talked about the classification problem, I mentioned one very important naive Bayes model. Okay, naive Bayes is based on the Bayes theorem, which is also derived from conditional probability. I think I'll share that in the group about the conditional probability. Yeah, so let's go on to the next step of discussing the unsupervised learning. And as I said about unsupervised learning, we have this is a problem that involves finding the pattern from input data without references to labeled outcomes. We have two major models in unsupervised learning, where you have clustering and dimensionality reduction. Those are the two problems that we handle in unsupervised learning. We have another kind of learning that is important. Okay, it is an hybrid of the traditional machine learning that is called ensemble learning. I've typed the name. This is the spelling of the new learning. Can someone tell me what does that mean? Ensemble learning. Who has come across ensemble learning there? Maybe. as they read about machine learning, your research, you have seen something like ensemble learning. When you're dealing with something like random forest, who can give a brief description of what is ensemble learning? Kaidu. Hey, Kaidu, can someone give the description of what is ensemble learning? Okay, maybe I will define it shortly. So, ensemble learning is where we use multiple machine learning algorithms together for the same task. Maybe you want to predict which team will win for the example that I gave, or maybe in the high risk data set, you want to predict which species that does a flower with this sepal width, sepal length, petal width, petal length belongs to. So in such a situation, you might combine decision tree, maybe linear regression or linear model, or logistic regression to predict the species of the flower. Yeah, thank you very much, Okom. It's the process in which multiple models are put together to outcomes. Yeah, that is the best description. That is the best definition of ensemble learning. We are using multiple machine learning algorithm for the same purpose or for the same task, and compare out of the three, majority says this flower belongs to which species, or says which team will win in a given match. So the purpose of having ensemble learning is to improve the outcomes of the accuracy of the model. So using ensemble learn, we get better prediction than using traditional models. And something that I want to clarify here is something that we call learners. Okay, each model in ensemble learning are called learners. Hizo models zenye umetumia kama umetumia linear regression and decision tree, that those two models, each is called a learner. And I would say this: accuracy of each ensemble learning model should be better that the accuracy of than the accuracy of each individual machine learning model. When you have used one model and when you have used the ensemble learning principle, the ensemble learning technique, you are to get the better accuracy when you're using ensemble learning that when you're using individual machine learning algorithm. And I will say, when do we use ensemble learning, or when is it the best time to use ensemble learning? Okay, we use ensemble learning in a case that one single model will cause overfitting. There are in such situations that you meet that when you use one single model, it won't predict correctly unless you do what? Unless you overfit the data. And to avoid that situation or scenario in your machine learning project, what you do is you implement or you make use of any ensemble learning model. Another reason of all when or where to use ensemble learning is when the result you get from one model are worthy what we call the training. Instead of retraining your whole model, you can simplify the process by using any ensemble learning algorithm. And the good thing with the ensemble learning, you can apply ensemble learning in both classification and regression problems. So I would say the importance of using ensemble learning is you get better accuracy, you get higher consistency, and higher consistency will resort to avoiding overfitting in your models. Another thing, it reduces bias and variance errors. Can someone check for me, or who can describe or give a brief description of what is bias and variance errors? Kindly check on that. Anyone with a clue? Yeah, I'm not presenting anything, I'm just talking. So I don't have any slides. I'm just talking, yeah. Uh, so I don't have I don't have any slides. I will just present my screen when I'm sharing the project. And thank you, Collins, for sharing what is bias and variance error. So I was replying to Okomo Jacob when I said, yeah, the things I'm saying, I don't have them written anywhere or in slides. Maybe I can write an article later. Yeah, I'm just presenting offered, and I think I'm sharing what I think I've been doing for few years on my research on machine learning. So I think I will discuss more on classes of ensemble learning. We have three classes of ensemble learning. The first one is stacking, but we won't handle it. It's more complex. The other type of ensemble learning is boosting. Boosting is a good example of a boosting model is when you're using XGBoost. Anyone who has looked at XGBoost, I'm just sharing it right now. XGBoost. Question, but I was saying there are three categories of ensemble learning. We have stacking, the stack data structure. Yeah. The next one is, yeah, I have typed the stacking. The other one is bagging. Bagging. The last one is boosting. So example of boosting is when you're using Python XGBoost. About any of these, you can check on me on Twitter, or you can DM me screen. But bagging is when you're using something like decision Ladon Forest. Yeah, Ladon Forest is a combination of many decision trees. Then boosting is when you're using XGBoost. Stacking is more complex and they don't touch on it now, but you can check on it later. So I'm done explaining what is machine learning. Okay, at Data Science East Africa, we have a culture of using a certain data science or machine learning pipeline. This is the way we do things. Anytime we want to handle any problem at Data Science East Africa, we follow a certain defined pipeline, and I'm sharing it. The acronym O S. Then we have E. Then we have M. Then we have N for interpreting. Then we deploy our model. Okay, if you omit the D that I have typed, we call it OSNAME. Yeah, so we start from okay, sorry. I was talking about OSNAME. Kindly give me 1 minute. Okay, sorry guys. So yeah, I was tied up kidogo, so we can go on. I was discussing about OSNAME, and I think I'm required to end my session very early. I have to go somewhere. So I was discussing OSNAME, where we start by obtaining data, then we scrabble, we clean the data, then we do the analysis. After that, we do the modeling. After the modeling, we interpret our results, and after our results are interpreted, we deploy our model using two frameworks in deployment process. We use Fast API or Flask framework, which are Python framework for deploying our model. So I think I've talked a lot. It's time to open Jupyter Notebook and start coding. Unless you have any question. If you have any question for me, just unmute your mic and talk. Kindly. Kindly, if you have any question for me, just ask. Anything about machine learning, anything. Okay, Jacob, are you part of the Data Science East Africa bootcamp? The January bootcamp? Kindly respond. The E is for EDA, exploratory data analysis, where you want to clean the data. N is for interpreting your results after you model. Which inferences can you make from your data? The other one is D for deploying your models now. You can't take to client models align kwa Jupyter Notebook. You have to compile it in a Python file. Then you have to develop a requirement.txt file, and you have to pick your model, create an API, and integrate in your application. Like I have a good application example that I want to share. Just check. Yeah, I want to share the recommender system by. I want to share a recommender system by Amazon. Yeah. Okay, this is a recommender system by Amazon. I'll be sharing where when you look at a certain book, they recommend for you a certain book that you can buy, or a certain book that buyers who buy this book also buys the other book. So I don't know why it's not loading. So you can just visit it Amazon and check on any books. They will give you a recommendation to buy another new book. So yeah, that's it. So we can start on the coding part. And kindly allow me to do this only for 20 minutes. At 4, I have to be somewhere. Let me share my screen. Yeah, I think the book, the recommender part is, yeah. This is the first part. Can you see my screen? Can someone confirm if you can see my screen? Kindly. Can you see my screen?
Yes.
Yeah, thank you. So what I'm saying, when you look at the page, you're trying to buy one book. The book is The Art of Science, The Art and the Science of Algorithms That Make Sense of Data. When you look at it, you can see a recommender system. Now, this is a system that is ML powered. That is machine learning powered. It recommends for you a certain book depending on the book that, sorry for that. It recommends for you a certain book depending on the book that you're looking at currently. The other thing that I want to talk about now is the coding part. Let me share that screen. Yeah. Can you see my screen? I want to start. Yeah, kindly confirm if you can see my screen. That's a simple machine learning algorithm. I think I'll do another I think I'll do another session later. So you start, as I said, you start by importing your data set, but currently you'll be using some data sets that are provided by Seaborn. Yeah. So I have to import Seaborn. But first I have to show some few acts on Jupyter Notebook. Sorry for that again. Okay, I'm having trouble. Yeah. So this is an example. So I want to help you out navigate Jupyter Notebook very fast. The first one is how to introduce a cell below any cell that you have. So the first thing you have to press escape. Okay, look at what happens when I press escape. Maybe I was typing import Seaborn SNS, and I want to introduce a cell below it. I will press escape, then I press B for below, and I can type anything like import padas as pd, padas as pd, and I want to introduce a cell above it, so I will press escape for escape, then I will press A for above. Let's say I was typing anything, print we can say print ml is cool, and I don't want to use that. I don't want to use that line, so I want to comment it out. You place control and forward slash to comment a line on Jupyter Notebook. The other thing I wanted to say, how to uncomment it, use control forward slash again to reverse the process. Another thing, control A for control highlight all. The other thing is control Z for undo. Another thing is control undo. Then control Y for redo. Then control X for cut. Control V for pasting, and control copy for copying the text from a certain cell. So I think we are clear there. Are we together? If I'm very fast, please confirm on the chat box. Hey, I want to see Paluja elewa useme tu kwa chat box. Please. Are you learning anything? Can you type anything if you are learning anything? Just anything that you have known that is new, maybe that will help you speed up your process. Okay, thank you guys. So I think I'll go on. Yeah, let me go on. Thank you. So I don't know. Okay, there is another thing when you're trying to import. Okay, don't know, let me escape it below, and I try to import py forest. Yeah. Okay, I forgot to tell you one more thing about Jupyter Notebook. When you want to run a certain cell, let's say I'm in this cell and I want to make a list. X is equals to, then I can have 20, 30, 50. I press Control Enter. It will execute the code in that cell. So even Control Enter is a shortcut in Jupyter Notebook to execute the cell. Let me escape and introduce a below cell. And I want to learn all cells. To learn all cells, look at how I do it. On the navigation bar that we have, there is something that is called learn. When you put your cursor there, you see a drop down with a lot of description. And the second last command in the drop down is learn all cell. When I click there, in the Python 3 on the right hand corner, utaona iko black. Mpaka I execute, it will remain black until it execute all the cells. Yeah, let's just
I can't hear anything. Please.
Harun.
Hello, excuse me, Harun. We can't hear you from our side, or is it only my side? I cannot hear like what you're saying. I can only see your casa and your notebook.
Hey, I realized I had muted my mic. So hey, kindly sorry for that. Sorry. So I even don't know. I had muted my mic and I don't know pali niliachia. Can someone remind me? The last thing that you had from me was, hey, kindly tell me the last thing that you had from me. Jesus. Then niliachia mbali. So yeah, I will very first discuss what I said. So the first thing is I imported the libraries. The other thing I imported the matplotlib, the library that I used to do visualization. Then I imported okay, a scalan. I can undo that. Let me tell you something about the scalan. A scalan comes with already made these machine learning algorithms. The first one that we can see is decision tree, which is a machine learning algorithm in scalan tree model. That's why I wrote from scalan.tree. So tree is a module that is in scalan that contains a certain machine learning algorithm called decision tree. Are we together? Okay, sorry for that. Let me share. You can see it now. Can you see my screen now? Yeah, sorry for inconveniences. So yeah, so I was saying the first thing that I did, I imported the Seaborn library. Then the second thing that I did, I imported the matplotlib library, but I even won't use it for that case. Then what I was discussing is here, when you look at sklearn, I wrote from sklearn.tree import decision tree classifier. So sklearn comes with the models or the machine learning models that are pre-built. So inside the sklearn, we have a module called tree, and inside that module we have a class which is a decision tree classifier machine learning algorithm, or we have a class that defines the DTC machine learning algorithm. The other thing I imported is another machine learning algorithm that is called in sklearn, that is support vector machine. And the last thing from sklearn dot model selection, we won't even use this one, so I'll comment it out. Yeah, I'll comment that one out. I'll even comment this one out and then comment the decision tree. I want the first thing that we do is decision tree classification. So after that, I load in the data set. That one is the one we called obtaining the data set in the machine learning. Okay, yeah, let me zoom. So the other one is I wrote in the data set that is obtaining the data sets. Then I viewed the data set. I counted to see what is contained in the data set. And there you'll get there is sepal length here. Then, sorry for that. Yeah, so you meet there is sepal length, sepal width, petal length, and petal width. Also, there is data.drop. I want to specify only the data that I will use to specify what? To specify the type of the species that flower belongs to. Then after that, I split the data, but I won't be using it for this case. So I will comment it out and comment by decision tree. So up here, you can see from sklearn.tree, which we have said is a module that is in sklearn, import decision tree classifier. And we made an instance of our machine learning algorithm. We defined a variable that stored our machine learning algorithm there in a variable called model. Then the first thing that you do, hata wakati tutakuwa tunatumia TensorFlow, these are the two major steps which you won't avoid. The first step that you won't avoid is to fit our model, then use our model to predict our results. So you can see after I made an instance of my decision tree, okay, so you can see the first thing I did, I made an instance of the machine learning algorithm that I have. So that is decision tree classifier. After that, okay, after that, I have made an instance of my learning algorithm that I will use. Then the next thing I do, I fit my data. So we define the data X that contains the data that we are using, or which are inputs. Then they are used to predict species. We made an instance of species or a variable to store the species data, which our labels for this case are what is the thing that we want to predict. So that is the data that we are using to fit our model. After fitting our model, you predict our model. And you can see you can provide any data set that we have to predict our model. That's why I have put 4, 5, 4, 4, 4, sepal length, then sepal width I put 5, then I put 3 for the petal length, and for petal width I put 2. And I think our model predicted correctly. Let's check if it did. Anyway, sorry, I didn't run this step, and that means I haven't run everything. So I'll come here up and run all cells. And just give it time. Okay, I will comment this one so that we can't get the error, and I will run it. So you can see it predicting that the type of the floor that you have is this color, which is the other type or the species of the flower that you have. So the types of the flowers that you have Citrosa, you have this color, and the other one you have is Virginica. So that one we use the first model, which is decision tree. I want to use I want to use the support vector model now that we have here. So I will uncomment it and make an instance of it at bottom here. So, but you can't have two variables with the same name. So what I will do, I will comment the other one. No, I want to use both of them to predict the result. So I will rename this one to model 1. Then here I will escape. I will escape and introduce a new cell below. Then I will use model 1. Okay, let me do one thing here. I will just highlight everything and copy and paste in the other cell. But now I love model 1, and model 1 is the one we are using for predicting. And we can name result 1 so that here we can have a cell below and print the result 1 there. So I will learn all the cells again. Learn all cells, and we will get the output of the other flower. Now you can see we used 2 different machine learning algorithms, and both they predicted that a certain this type of description, the sepal length, sepal width, petal length, and petal width that I have given to be 4, 5, 3, and 2, they belong to each species of all our labels. Okay, pollen. They belong to each species of our data set. Now you can see both of them, they predicting that it is in the same species. So that done, I will also handle the part of the you want to check the accuracy of our data set. But before you check our accuracy, you have to split. So sklearn, which is a machine learning algorithm, Python machine learning algorithms, comes with a module that we call model selection. So model selection, it contains a method that we call train test split. So how to import it, you do from sklearn.model underscore selection, import train test split. That is how you import the package. Then you use that one to split your data set into 2 categories: test and the train data set. Another thing I didn't mention is that every time you have your X in uppercase and lowercase. So I will uncomment this one too. And as I said, we can compare the score or how accurate our model is using the score method that comes with our machine learning algorithm. So when we imported the decision tree classifier or the support vector machine, when we imported it to our file, it comes with a lot of method. So one of those methods is the fit, the other one is the predict. There is another one more now, which we call the score. This is the model that we use to test the accuracy of our model, and the correct syntax is, as you can see, we only use the test data set. That is the X test and the Y test. not defined, so you learn no cells. Just 1 minute. Yeah, let's see the result for that case. Now you can see our model is 100% accurate. That is, so okay, this is just a toy data set. This be 100% accurate. So when we used our decision tree classifier, we got 100% accuracy. And I want to introduce a cell below and get the model 1 and see what is the score. Okay, sorry. Control Y. Control copy. We want to see the accuracy when we use the support vector machine. That's why we have it that way. So you can see the accuracy changed for support vector machine and decision tree classifier. So you can see the decision tree classifier result of the score is 100%. The accuracy is tested from 0 to 1, where 0.1 represents percent and 1 represent 100%. 0 represent 0%. So you can see the decision tree classifier had 100% accuracy. And when we came to this, okay, support vector machine, we earned 96.66%. So in such a situation where you have similar data set, I would advise you use more than one machine learning algorithm and test the one that has a higher accuracy. The other thing, okay, I think I've added this file on getting the score. That was what I was discussing. So I want to use we look at two more things. The first one is saving your machine learning model. The third one, the other fourth thing is how you can visualize your decision tree. Okay, just give me just a moment. Yeah, I think I'll delete something. Okay, there is one more shortcut I didn't mention. Sorry for that. When you want to delete a cell, like I want to delete cell 4, I will just press escape and D twice to delete that cell. Then I want to run all the data sets so that we can see. So, but before I do that, let me explain the process of saving and relearning the model without pre-training your data again. So in sklearn comes with a package that we call joblib, and joblib is found in, okay, sometimes you'll get an error when you use externals to import joblib. Sometimes but for my case, okay, in my version of Anaconda, it worked that way. So I use externals, which is a module in sklearn, to import joblib. That is the only package that I need to save my machine learning algorithm. Now you can see, okay, I don't need even set 2, so I will escape and B. Yeah. So similarly, you import the packages. Another thing I can mention is that you can use PY forest to simplify this process, where you write, instead of the importing the instead of importing the 6 packages independently, you can just use one line, which is import PY forest. Are we together? Any clarification? Are you learning anything? Can you just confirm on the chat box? Yeah, so we can go on. Let's go on. So as usual, import the data set. Let me remove the typo there. So after you import the packages, then import the data set. Then you classify the inputted, the out the labels. Inputs are the data that you use to predict. Labels are what do you want to predict. I want to use the if a team will win in that match. The away score and home score are the input to predict the label, which is the output the team will win in a certain match. I don't know. Sijui kama tunaelewanwa. There is labels and inputs in any machine learning algorithm. I won't repeat anymore. So after that, I think you know how to make an instance of your machine learning algorithm. Then the next thing you do is you fit the model, and you fit the model using the input and the input and the labels, or the input or the and the output. Then the joblib package that we imported comes with a method called dump. I don't know if you're understanding. So unaangalia in the third line of our first cell, we have from externals import joblib. Then when we come in cell 12, if you can look at it, we have joblib.dump. So it comes with the dump method, which takes two arguments. The first one is the method that you want to save, and dump method is used to save the model that you have fitted. So the first thing that happens, you have two arguments from in the dump method. The first one is the method that you want to save, and the other one is the project or the file name, how you want to save that model. In Python, you save any Python package as maybe app.py. But when saving a machine learning algorithm using joblib, you use an extension called .joblib. That's why you see I've saved a model called project1.joblib. Then the other thing in joblib, it comes with another method that is called load. The load method in joblib is used to load our saved file. So the way you can write a Python function to calculate the average of a student marks, save that file, import it in a new file, and use it to calculate the average of marks of another student taking similar courses. The same thing you do here. You create a model, you save the model, then you load the model. You won't fit the model again. You just load the model and use your model to make predictions. Okay? So that's why I made instances of the saved model, and I used the model to predict. Hey, confirm if you are together so that you can go in the other cell. Anything that you want to clarify in that cell? People, can someone type anything? Okay, let's look at the last thing that I wanted to look at today, and we can call it a day. So the other thing I wanted is how to visualize our machine learning model. And I don't know if I still have the file. Yeah, the file is here. So there is another package that I wanted to look at that comes with sklearn, but it is available in the tree module that is imported when you import the sklearn. So the first thing you do the similar thing, then you fit your model. Okay, import the packages, load the data set. Then you define your inputs, that is your input and the labels. Then you make an instance of your machine learning algorithm. Then you fit your machine learning algorithm. But now you can see you're using decision tree. You can visualize your decision tree. Just 1 minute. Sangapi? Okay, sijui nilikuwa nafanya nini kimya tu. Hata sijui nimeachia wapi. Fuck me. Okay, I don't know pali niliachia. Can someone confirm the last thing they had? Okay, I think I'll discuss the whole file again. So let me learn the whole cell. Someone has confirmed. Thank you. So I have to delete this. Yes, created a file there. And I think. So, okay, thank you. So I made an instance of the model. Then the other thing, to avoid such errors, you can add semicolon. Yeah, sometimes you make a plot using matplotlib or seaborn and you get a certain error. You can avoid that error by using semicolon. Yeah, it's very important to note that. Jupyter Notebook semicolons, it eliminates some few errors. So after that, I was discussing that we have export graph visualization model. So that how you do it. And export graph visualization takes a number of arguments. The first one is the model that the other one is out_file, how you want that decision tree saved. And you have to know that the decision tree files takes an extension. There you have a Python file with a .py extension. Here we have a dot alafu dot. It also takes labels, which are your output, the one you want to predict. Then loaded, if you want your decision tree, each element to be loaded, that is a Boolean operator. Then we have field, which result values, that is true or false, Boolean operator. So one thing I can do, I can try to run my tree here so that we can look at it, how it appears. So I just can define a variable here, my tree. Using the shortcut and run it. When you learn all these cells, you'll get this result. Example dot. So this explains how look like. So the last thing I want to do is how to visualize the tree. So I will come to VS Code and install an extension that we call graph visual. It's taking forever. So what I will do on VS Code, let me share VS Code instead. So yeah, I will share VS Code. Then not here. So I want to install an extension. So I will look for an extension called graph is short form for graph visualization. I can also have dot here. Yeah, so I have to import this language by Joao Pinto. So you can click on it and install. Just wait a few minutes. Eh. Just give it a few minutes to install. Then after installation is complete, just I'll stop sharing that screen so that I can demonstrate something. I'll just give it time to install the extension. You have to drag the file now that you have. So I have to navigate to the place that I have that file. Here, it was in my desktop. Then a package called Python. Then I will look for a file called example.dot. So here is the file. So I have to wait for the extension to complete. And that I'm not sharing. Hey, just a minute, I installed the extension, but you can also try to install in your local machines. When you install it, I think I can use something else. Yeah. Sababu nimefanya.
Hi guys, so our speaker has a power outage, so I think that's where we shall end the meeting and resume next time. Thank you all who attended. Thank you.